First of all, Dr. Saha is working as Director of Infrastructure Design Consultants Private Limited. He is also associated as consultant in highways and pavement with the World Bank since 2012. He obtained his MTech Geotech from IIT Delhi and have done PhD from IIT Bombay. He has been working in the field of highways and payments for last 30 years in various organizations. So today, Dr. Saha uh, will deliver his presentation on use of reclaimed asphalt pavement in granular surface and base construction in flexible. So I request Dr. Dulal Saha to take over.
Thank you, madam. Thank you very much. And good morning to all participants. Actually, today's presentation was to be given by Professor J.N. Mondal on use of geosynthetics in pavement. Somehow he could not attend, and he has asked me to give a presentation, and the topic is also changed, and that topic is use of reclaimed asphalt pavement in subbase and base of flexible pavement construction. Objective of the study was to see whether we can use waste material in pavement construction. As already explained, that my name is Dulal Saha, and I graduated from Jalandhar University, and subsequently I have done masters and PhD from Delhi and Bombay respectively, working there with IDC Mumbai, and also a consultant to World Bank for their various mission in India, especially. So the presentation has got few. The outline of the presentation is such that I'll start with a little introduction, and the study has got some objective. I had a little motivation also to start this study, done some literature survey as it is associated with all studies, and the total study was divided into two parts. The one was stabilization of RAP, and the other one was reinforced RAP. To see whether RAP can be utilized in bituminous pavement construction, especially in the base and sub-base, either by stabilization or by reinforcing it. And after this study, some conclusion was made. It was published in a few journals, international journals, as well as some conferences. And the details I would like to share with you in this presentation. So the basic idea is we have got a huge road network in India. It is close to 6 million kilometers. About 2% is national highway and 3% is state highway. Rest of the things are major district roads, other district roads, village roads, and all other roads. Most of the roads are having bituminous pavement. And as we know very well, bituminous pavement needs regular maintenance and attention sort of thing, not only because of the traffic loading, but also because of the environmental factors. I mean, even if there is zero traffic on that, zero traffic, I'm saying that even if only car traffic is there, like there are few roads in Mumbai where no heavy traffic is allowed, only car traffic is plying on it for a very long time. And we know that car traffic's loading is not considered for pavement design. Even that type of road also requires some sort of maintenance. It is because of weathering and climatic situation. And over and above this maintenance of this huge road network, we in India have got a huge planning, a very big planning of improving increasing our road network. As we know that NHDP has got about 28,000 kilometers, Bharatmala has got about 84,000 kilometers. Over and above that, BRT, that is backward religious and tourist place connectivity, which was there about 6-7 years back, it was introduced, and PMGSY is also there. So the existing road network as well as the new one.
Sorry, sir, to disturb you, sir. Your slide is not visible.
Slide is not visible?
No, sir. So you have to go in present now.
Is it now visible?
No, sir. So actually, you have to present now. There is an option on the Google Meet screen.
Okay, I'll just try.
Right hand side.
I'll just try. Is it visible now?
Yes, sir. Yes, sir. Thank you, sir.
Okay,
Sir,
I'm sorry.
height
I'm
is
sorry for
visible.
the, yeah, I'm sorry for the inconvenience. So I start from the beginning.
Sir, please hide that button.
Pardon?
There is a Google Meet.com sharing on your screen. You have to
Mm-hmm.
hide it. Okay, fine. It's okay, sir.
It is okay?
Yes, sir. Yes, sir. It's fine, sir.
Okay, okay, okay.
Okay, thank you, sir.
Yeah, thank you. So as I said that we have got a huge existing road network, and we have got a lot of planning also for road construction in India. And in this huge road network, majority of the roads are bituminous pavement, and bituminous pavement needs repair and maintaining on a very regular basis. And these repair activities and maintenance activities. Sorry, sorry, is it audible?
You can continue, sir. Yeah, sorry.
Okay, okay. So these requires use construction material, and available resources being limited, there is a need to find out alternative material. And this was the objective of this presentation, to find waste material as a tool for using in the new construction. So in this study, what we have done is we try to use RAP, which is generally obtained from milling or full depth removal of the existing bituminous pavement. Try to mix with crusher waste. I mean, for each and every road construction site, crushers are installed to get various gradations of material, stone material. And there is a huge waste, crusher waste. We call it crusher dust also. Generally, it is not utilized in any place. So in this study, what we try to do is, we try to mix RAP with crusher waste, and then try to find out whether this mix of RAP and crusher waste can be utilized in any of the two granular layers, like GSB or WMM. And in this study, we found that along with RAP and crusher waste, we need to use a small percentage of cement. And once we have used that, then the two basic parameter of this granular material, that is strength in terms of CBR and UCS, has improved substantially, and which was satisfying the requirement of subbase actually in this case as per our IRC consideration. So that was one part of the objective, and the second part of the objective is the RAP has been utilized. Reinforced RAP with polymer geocells has been utilized in many places. There are many research papers also available. But here what we try to do is we combined geocells with polymer geocells with geogrid, and we found that the combined effect was much more than the use of only geocell. And along with that, another new material has been utilized, bamboo geogrid and bamboo geocell. So as I said, the two part of the study, one was stabilized RAP. Stabilization was made using RAP with crusher waste and cement, and another one was reinforced RAP. That is, RAP was reinforced with bamboo geogrid bamboo GSL and polymer geogrid polymer GSL. So we found that in both these three categories, the improvement was such, load carrying capacity improvement was such, that it could have been used as an alternative material for base and subbase, the details of which we'll try to show in our subsequent slides. As I said, there was a little motivation, like as I have been working for road highway sector since 1988. We found that when there is a program for upgradation of existing 2 lanes to 4 lanes or 6 lanes, we try to give cross connecting facilities in terms of BUPs and PUPs, and many times flyovers also. And wherever these grade separators are used, the profile of the existing road is changed. And earlier it was 33%. I mean, 1 in 30, that is 3.3% was the allowable gradient, longitudinal gradient. Now, subsequently, it has been reduced to 2.5%. That is 1 in 40 gradient is required. Now, once we have changed this profile from here to here, Say for example, if we are talking about a flyover, this height becomes about 5.5 plus girder thickness and all other things, it comes about 8 meter. 8 into 40, close to 300 meter on either side. That means 600 millimeter for each grade separator, each cross connecting facility. And the new PPP manual, like 4-lane, 6-lane manual, the requirement is generally every 4 to 5 kilometer we need to go for across connecting facilities in terms of some underpasses or flyovers. So generally it is found that about 20 to 15 to 20% of the existing materials are buried. Again, the objective was if this existing material can be taken out and it can be utilized in some form or the other. So basically the main objective was we take the bituminous material out and try to use this bituminous material for bituminous mix preparation. But for bituminous mix preparation, the quality of the material requirement is very, very high standard. For any reason, if that material, extracted material, cannot be utilized in bituminous mix, then instead of dumping it in the dump yard or low-lying areas or using it as embankment, if we could use it as base and sub-base, then probably we get a better road and we get cost benefit also. Of course, if the bituminous material could be utilized for bituminous material construction, the financial benefit is the highest. But it is associated with very high quality of wrap material and uniform wrap material. If it is not possible, the next best utilization is in the base and sub-base, and that is where my study was limited. Now we saw that if it could be utilized even in base and sub-bases, we can not only utilize the waste material, but also we can save some money. We can get financial benefit in road construction activities. As we know, generally we have got 3 types of pavement in general: flexible pavement, rigid pavement, and another paver block pavement. Mainly in the city areas near almost all junctions it is proposed, and probably at some places in the ports where heavy containers and all other things are used, this type of pavements are there. In the bituminous, we have 2 layers of bituminous material and then base, sub-base, subgrade. And in this base and sub-base only we will try to use this waste material, that is wrapped, either stabilized or reinforced. I mean, rigid pavement is also there. Bituminous layer is replaced by PQC and DLC. We will not do anything here because our study presentation is fully dedicated to bituminous pavement only. Similarly, we will not talk about the paver block pavement also. Here, after the base, we need to have a granular layer, coarse sand bedding, and then we need to put this interlocking paver block, either 60 millimeter to 100 millimeter to 60 millimeter to 100 millimeter. For a low category road, it can be 60 millimeter interlocking paver block, 80 millimeter interlocking paver block, and very heavy area we need to go for 100 millimeter. So as we know, the pressure distribution for rigid pavement, it is a little uniform, naturally, because pressure is distributed over a wider area. But for flexible pavement, it is like this. Load is concentrated and pressure is not uniformly distributed for the wider area. Now this reclaimed material, as I said, that basically there are 2 sources of finding out this reclaimed material. One is, as I said, that regular maintenance is required for all bituminous pavement. We need to give overlay in terms of 3 to 5 years in general. And before overlay, we need to mill also for 2 reasons. One is we cannot keep on increasing the level of the existing road because other facilities will be hampered in that. So we need to mill it. And another thing is that if we put only overlay without taking out the existing material by some portion, maybe because of reflection tracking, the existing pavement may not perform well. So generally what we do is we try to mill some portion of the existing material depending upon the condition of the road, generally 50 millimeter, 40 to 50 millimeter it is milled. And these mill materials are taken from almost all national highway projects and important state highway projects. There are huge quantities of wrap material, mill material available. And another thing is that while constructing the road, there are a lot of waste or excess mix or rejected mix also generated. So these are the 2 sources of wrap material mainly. And another thing is that at times we need to completely remove the existing material for reconstruction if the condition of the road is very poor. From there also we can generate this wrap. This wrap, if it is properly piled, properly stored, without mixing with each other, then probably it can be replaced in various layers of pigments. We tried to find out the properties of the RAF. We generally found that generally it is from the top layers, it is 20 millimeter down. I mean, asphalt content is 2 to 3%. In my case, I got about 2.8 to 3.2%. Compacted unit weight, I found about 2 ton per meter cube, that is 1.9 to 2.2 gram per cc or ton per meter cube. For 100% RAP, the CBR value was 10 to 20%, unsoaked and soaked. And once I have mixed with crusher waste and cement, I found CBR value much more than 100%. We'll discuss this improvement in CBR value later on in the subsequent slides. So as I said, I studied some literature also, and I found that RAP generally has got CBR value in the range of 10 to 20%, whereas for base and sub-base, the requirement of CBR is 30 and 100%. For sub-base, it is 30%, and base, it is 100%. So generally, RAP is considered weaker. It needs some sort of improvement, and that improvement till now, what people have said is either it is mixed with virgin aggregates or virgin aggregates mixed with virgin aggregate and stabilized with cement and cement or lime, fly ash, cement or fly ash. Here I try to do is I did not mix RAP with virgin aggregates. I try to mix with another waste, that is crusher waste, which is available in huge quantity in each road projects. And generally it is found that RAP when mixed with virgin aggregates, CBR value increases. And when it is mixed with virgin aggregates and stabilized with cement, even UCS value also increase. And RAP reinforced with geocell, it is observed that load carrying capacity of the layer increases substantially. So there are two different things which I have done here. One is, as I said, that we have mixed RAP with waste material, that is crusher waste, instead of virgin aggregate, and then try to analyze this analyze pavement utilizing this stabilized sub-base material using IRC 37, that is IIT PAVE, and then found the fatigue and rutting life. Try to find alternative pavement composition and compare the requirement of material as well as the cost, and found that less material is required and cost savings are also there. And we have done some model tests, and in this model test we have used polymer geogrid and geocell and bamboo geogrid and geocell to see the increment in load carrying capacity of the layer. So seeing that load carrying capacity of the layer, we try to find out how the improvement can be achieved. So basic study was in two categories, as I said. First was purely laboratory tests. We tried to find out series of CBRs and UCS on RAP mixed with crusher waste and cement. And the second categories were of testing were model test. And in this model test, clay subgrade, clay bed was used. And then we tried to find out the load settlement behavior of RAP material placed on clay, reinforced and unreinforced. And we try to do the similar sort of model test using WMM material, which is generally used as base material. And then we try to use WMM RAP material to see how the improvements are there. So this one was in WMM, reinforced and unreinforced. And the third category of model tests were mixture of WMM and RAP, reinforced and unreinforced. In all the three cases, the subgrades marine clay taken from JNPT, Indian Mumbai. Laboratory tests are something like this. As I said, that for sub-base, requirement of CBR value is 30% and UCS value was 1.5% for bound sub-base. For base, it is 100% and 4.5%. And we have seen the CBR value of RAP is less than even 30%, so it needs to be improved. So we have improved it by mixing it with crusher waste and stabilized with cement. And we have observed that 50% RAP, 50% crusher waste, and 2.5% cement gives CBR value more than 100%, and 4% cement gives UCS value more than 1.5 MPa. So the requirement was 1.5 MPa UCS, more than 30% CBR. So this was my combination: 50% RAP, 50% crusher waste, 4% cement, which was giving more than 100% CBR, and more than 1.5 MPa unconfined compressive strength, satisfying the requirement, of course, satisfying the gradation also of using this mixer as sub-base for flexible equipment as per IRC 37. The testing schedules are like this. We have made tests on 100% RAP material and then tried to reduce the RAP material and increase the CSA material. It was like 100, 75, 25, 50, 50, 25, 75, and 0, 100. And for all the combinations, varied the cement content from 0 to 6% every 2%, 0%, 2%, 4%, 6%, and try to see how the CBR value is increasing or changing both soaked and unsoaked CBR value. Few of the results are like this. Once we used 100%, 100% RAP without mixing it with any crusher waste, we found that soaked CBR value increased from 20% to 75%. That means 100% RAP with 0% CBR and 100% RAP with, say, for example, 4% CBR. The increment in CBR value was 20 to close to 40. Once we have done 50-50, 50% RAP and 50% crusher waste with cement, varying percentage of cement, we found that with 2.5% cement, 50% RAP, 50% CSA, and 2.5% cement, I get 100% CBR. So increase of CBR was very, very substantial. So that was the requirement. Like based on CBR criteria, 50% RAP, 50% crusher waste, 2.5% cement exceeds CBR value of 100%. And if we see, both these materials are waste material. RAP was also waste because most of the cases it is only dumped. It is not used in normal pavement construction in full force even today. And crusher waste, of course, is also waste. It is not used in anything. After that, similar sort of test we have done, similar sort of materials we have tested for unconfined compressive strength. Here also the samples were like 100% RAP, 75-25 RAP and crusher waste, 50-50, 25-75 and 0-100. And all these categories were tested with varying percentage of cement, 0, 2, 4 and 6. And this sample was 75 millimeter diameter, bigger size sample, not smaller size sample. Initially, it was very difficult to do the sample. Then afterwards, after a lot of trying, just trial and error, these samples were coming quite nice. Here also, we have seen that for 100% RAP, with increase in CBR, increase in cement percentage, UCS value increment was not very, very substantial. That means 445 kPa to 450 kPa. But 50-50, when you are using 50-50, that is 50% RAP, 50% waste, with increasing cement, with some percentage of cement, we found that 50% RAP, 50% CSA with 4% cement, UCS value was exceeding 1.5 MPa, which is the requirement for bound surface. This is what our requirement was. So to sum up this CBR and UCS test categories, general observation was waste RAP, waste from crusher with about 4% cement satisfied both the CBR and UCS requirement for using as sub-base for flexible equipment. Then we try to analyze this alternative pavement composition in IRC 37 using IIT PAVE, and then this is what we have found. These were the parameters, like as we said, sub-base has a requirement of 30% CBR and 1.5 MPa, of course, if it is bound and it is a crusher aggregate or stabilized sub-base. For base, it is 100% and 4.5 MPa for bound base, of course. But for untreated RAP, the CBR value was 10 to 20%, and UCS value was this. It was not suitable even for sub-base. But the moment it was stabilized, 50% RAP, 50% CSA, and 2 to 4% cement, we found CBR value was increased more than 100%, and UCS value was increased more than 1.5 MPa, the MPa that was suitable for sub-base construction. Now, these are the two compositions which we have taken, and for this we have taken 10 MSA design traffic, I mean relatively less trafficked road with very low CBR value of 3%. We found in marine clay 2.5 to 3% CBR. And then from IRC 37, this was the composition we have got: 40 BC, 90 dBm, 250 WM, 380 CSB, and 500 sublet. This is the composition. And then alternative layer, we try to find out in trial and error method to see whether rutting and fatigue life is comparable to this. And for that purpose, I found 25 millimeter DC. You can say SDBC also. Like instead of 40 millimeter, it is 25 millimeter. Instead of 90 millimeter dBm, it was 50 millimeter dBm. Then 200 and 380, that has been reduced to 50 millimeter WMM, 150 millimeter stabilized wrap, stabilized subbase, that means 50-50 subbase and GS, wrap and CSA. And below that 150 millimeter GSB, we have proposed to ensure proper subsurface drainage, and subgrade was there for both the cases. We found that the reduction of material was about 30%. And then we tried to find out these two strain, tensile strain at the bottom of the bituminous layer, horizontal tensile strain, and the compressive strain on the bottom of, on the top of subgrade layer, because these are the two critical parameter for pavement design as per IRC 37 and So various parameters besides the thickness we have taken like this. Most of the cases we have used IRC 37 requirement only. Resilient modulus values for bituminous material, it has been taken 1700 MPa, and then WM material based on severe value of subgrade and thickness of various materials, we try to find out using empirical formula given in IRC 37. Poisson's ratio was, this value was also given in IRC 37. We have used that, and we have used the IIT to find out these two strains. And once these two strains are obtained, then we try to find out fatigue life and fatigue life using this empirical formula which is given in IRC 37, and found that these are the strains. And we found that for the conventional pavement, the life was 22.8 MSA, whereas for alternative pavement, it was 23.4 MSA. So we could see that with less than 30% less material and lesser cost, which I'll try to show in the next slide, our pavement life was better using these alternative pavement options, where both these waste materials have been utilized. Waste, I'm saying the wrap as waste, and then crusher dust as waste. So for cost analysis, as I said, I have considered a 2-lane road, 7-meter wide road, with considering 10 MSA design traffic and 3% subgrade CBR. So base case was this: 40 BC, 90 dBm, 250 WM, 380 CSB, 500 subgrade over 3% CBR. This was about as per IRC 37. And then alternative pavement options, I have considered this. I found this comparable to fatigue and fatigue life of this base case, that is 25 millimeter BC, 50 dBm, 150 WM, 150 millimeter stabilized wrap, that is 50% wrap, 50% waste, and 24% cement, and then GSB 150. Now, so this was the composition, and then we found that life is also better, marginally better, of course, and then cost was about 36% lesser. I mean, I have tried to take this cost based on rest analysis in somewhere this area in Maharashtra. So I could say that using wrap and crusher waste with 4% cement, if we could use this thing as subbase, replacement of subbase, we found that life is also increased, cost is also reduced. So we thought that this probably could be a better option to utilize it. With this, the first part of the presentation is completed. Now we'll come to the second part of the presentation, which is related to the model testing. And in this model testing, as I said, that I have taken the conventional material which can be utilized as base, that is WM material, and then try to use the performance of WM material, performance of wrap, reinforced wrap, and reinforced WM plus wrap with respect to this base material, that is WM material, and try to see how the pavement composition can be arrived at. And the model was something like this. We had used a tank, steel tank. It was manufactured specifically for this test. It was 600 by 600 by 600 tank, and this was the tank. And in this tank, bottom 300 millimeter, we have used soft marine clay bed, which was used as subgrade. Then we try to use geotextile separator to avoid this intermixing with whatever material we are using here with the soft marine clay layer below. And then we have used WMM material, as the basic material testing is WMM. So we have used WMM material here. The thickness of WMM material was 150 millimeter. Compacted, it was compacted in layers. And then we try to put this, what is it called? Loading plate. We can see it here. This was the tank. This is the loading plate, 150 millimeter by 150 millimeters. Then we have this LVDT for measuring the deflections diagonally placed opposite. And then loading was 10 ton capacity loading frame. It was available in the laboratory, and that has been used. So the first set of tests was WMM material reinforced with geogrid and geocell. And the models are looking like this: soft marine clay. This is geotextile separator, then WMM material. It was unreinforced. Unreinforced means this was the base case. And then we try to use this just over the geotextile separator. We have used geogrid, polymer geogrid, and then polymer geocell, combination of polymer geocell, and try to find out how the load carrying capacity is increased with respect to this unreinforced material. And we have found that substantial load carrying capacity increment is there in terms of load carrying capacity. And after that, we have used only this, compared only this basic WMM material. If it is reinforced with geocell and geogrid together, what is the improvement in load carrying capacity? We found that if we use polymer geogrid, load improvement factor is 1.2. Polymer geocell, it is 3.2, and 3.2 is geogrid plus geocell. And that means polymer reinforced WMM material has got better load carrying capacity, about 3.5 times. And 2.5 to 3 times have been obtained in various literatures also. Then we try to find out similar test sort of thing, use changing the reinforcement. We have used bamboo reinforcement. Here bamboo geogrid and geogrid was below, and these bamboo geocells are also there. And prepared the model in similar way and try to see how the load carrying capacity is increased. We found that bamboo geogrid was a little better in terms of load carrying capacity than polymer geogrid, whereas bamboo geocell was not as good as this, because there geocell plus geogrid was 3.28 improvement in load carrying capacity. Here it is only 2%. So a little lesser, but even then substantial. Load carrying capacity is multiplied by 2. So these three, this was the basic material. I have taken considering basic material because WMM is the basic material used for conventional flexible pavement. And my objective was to see whether reinforced wrap can be, WMM material can be replaced with reinforced wrap. So I tried to see try to compare unreinforced load carrying capacity of unreinforced WMM with reinforced wrap and see how it is coming. So with wrap also similar type of tests we have done. That means wrap reinforced with geogrid and geocell, exactly the similar way, only the material is changed. We have found this load carrying capacity also. Then we have found that improvement of load carrying capacity is there, because for WMM it was 3.28, but for wrap it is 2.6 only, but there are improvement in load carrying capacity. For bamboo, it is also improvement was there. And then I have tried to use this combination of WMM material and wrap, assuming that 100% wrap, instead of using 100% wrap, if we can mix WMM plus wrap and can see how the results are coming. There also this result was coming in between. So what I'll do is I'll try to find out the comparison. I mean, as I said, the basic objective was to utilize this wrap material, reinforced wrap material as a replacement of WMM material. Whether it is possible or not in terms of load carrying capacity, I was just trying to see. And from this comparison of test results, we'll be able to see that. Now, we have seen that improvement in load carrying capacity, if I use with respect to WMM material, unreinforced WMM is this. And if I use bamboo geogrid and bamboo geocell, so my improvement in load carrying capacity is about 25%. I use polymer geogrid and polymer geocell. My load carrying capacity increment is 1.83. But once I use WM plus wrap, bamboo geogrid and bamboo geocell is 1.39 and polymer geogrid and polymer geocell is 2.73. So unreinforced WM is this. This is the base case, which is normally used for pavement, flexible pavement construction. Then I am using bamboo reinforced wrap. I am getting this. I am using bamboo reinforced wrap plus WMM. I am getting this. If I use polymer reinforcement, only wrap is this. Combination of wrap and this thing is this. So what I wanted to say is, the moment I use reinforced wrap, either polymer or bamboo, it is performing, I mean, load carrying capacity of it is, this is much more than the load carrying capacity of conventional WMM material. And if it is polymer reinforced, then it is very, very high. If it is bamboo reinforced, then also it is high, but not as high as polymer. So from this, we concluded that wrap material could be utilized, reinforced wrap material could be utilized as an alternative material for even WMM material. We tried to do some sort of cost analysis also. Here also the same concept was there. The base case was conventional flexible pavement for 10 CBR traffic with 10 MSA traffic with 3% CBR, taking the composition as from the ARC37. And then after that, I try to use alternative base, alternative subbase. And this alternative base and alternative subbase, I have used equivalent thickness of alternative material using this improvement factor. Whatever improvement factor I have got this model test, I have tried to do this. I'll try to explain this thing like this. Say for example, if I use reinforced wrap as base, then my combination was this one. For 10 MSA traffic, 3% CBR. This combination was taken from IRC37. And my base was the reference point. 250 millimeter base was required. Now, keeping everything same, I tried to reduce this base material by reinforced wrap as base. So if I use bamboo geogrid, bamboo geocell, then equivalent thickness was 200 millimeter instead of 250 millimeter. I use polymer geogrid and polymer geocell, then equivalent thickness was 150 millimeter. Similarly, if I use this WM wrap material, this equivalent thickness was 180 and 150 respectively. So this was the alternative pavement. I mean, considering as alternative base, this is the basic, I mean, reference, and this is the alternative composition. Similarly, if I use subbase, if I want to use alternative as subbase, then my subbase was 380 millimeter. This 380 millimeter I try to replace with alternative material. That is here 330 GSB. I try to use reinforced GSB, either polymer reinforced GSB or bamboo reinforced GSB. Say for example, 380 millimeter GSB was replaced with 150 millimeter GSB and wrap reinforced with polymer geogrid and polymer GSB. Using these pavement layers, I found that using alternative base, the cost reduction is 6 to 10%. Alternative sub-base cost reduction is about 10 to 12%. So what we have seen is cost reduction is also there, load carrying capacity, cost reduction is also possible, and load carrying capacity improvement is also there. like conventional flexible pavement, as I said, has been used for cost comparison purpose. And as I said, like here, alternative base has given me a cost reduction of 6 to 10%. Alternative sub base has given me a cost reduction of 10 to 12%. So the overall conclusion of this study is like this. If I use stabilized wrap as sub base, stabilized means wrap stabilized with crusher waste and cement, cost reduction was obtained as 37%, reduction was about 30%. Similarly, if I use reinforced wrap as base or sub base, then cost reduction was varying from 6 to 12% basically, and material reduction was about 15%. So this was the basic objective. And after that, some of these results were published in these journals also. International Journal of Pavement Engineering, another one was International Journal of Pavement Research and Technology, and the third one was International Journal of Geosynthetics and Ground Equipment. These are the three journals, and then a few of the results were published in the international conferences and domestic conferences. Thank you. This is what I wanted to say. If there is any question, I will try to reply. Thank you very much.
Thank you, sir. There are a few queries in the chat box. You can have a look at.
Yes.
So you can press the button stop presenting.
Okay.
Then you can press on these icon adjacent to it, sir. You or the and then in chat box you can see the queries. Yes, sir. And again on another side there is a chat box. So you can read some queries.
Sorry, madam, I'm not able to find those.
Sir, where you are seeing green 33, some lines are there just as suggested. Yes.
The first one is something like this. Can we? It is from Ms. Manjula Devi. Can we correlate the load carrying improvement factor with any specification which is suggested by IRC 37? I mean, if I understood the question correctly, the basic material I have considered for this model testing was WMM material. Now this WMM material has got a specification. It is not there in IRC 37, it is there in MORTH. So WMM material utilized for base material as per MORTH has been taken as reference material. And then I have done testing on two basic alternative material. One is RAP and another one is the RAP plus WMM 50/50. So say for example, if I take my base material, I can compare it with that material. Like here I have considered WMM material as per MORTH specification and I have compared the load carrying capacity accordingly. I think this is my response to this. And then the second question was from Ms. Priyanka Sharma. How to calculate the improvement factor? As I said that we have taken the load settlement diagram, normalized load settlement diagram, and then compare when the settlement is stabilized, compare the loading, compare the load carrying capacity for this specific settlement for various type of material and see how the load settlement is there. Say for example, for WMM material, my load carrying capacity was 100 MPa, whereas when I have used RAP plus polymer modified, it is 120 MPa. So my load carrying improvement factor was 120 by 100, that is 1.2 MPa. This is how it was calculated. The next question was how to train contractors and laborers for using it, how to incorporate in PWD. So now, as I said, there are two specific. This question was from Mr. Jeet Swami. Now, sir, I think it is a very interesting question, and basic objective was to do this only so that something can be utilized in the actual field. And actually, there are two aspects of this. As I said, that the first one was stabilized RAP. Stabilized RAP means RAP mixed with crusher waste and cement. So it needs to be mixed separately. Like say for example, if we have seen while using this WMM material, we mix it in the pulp mill and then lay it and compact it. So here also in specific proportion, we need to mix it before and then lay it and then compact it. It is as simple as that. But as far as reinforcing this thing is concerned, it depends on which reinforcement material we are using. Now, say for example, we are going for this available material, not manufactured material, available material like factory made material like geocells and geogrid. There are specific ways of using geocells and geogrid in combination. Say for example, I want to use in the subbase. Now, if I want to use in the subbase, I said I'll construct the subgrade material, subgrade top properly, and then use this lay and compact this GSB layer for subsurface drainage. Over that only I am using this strength bearing alternative material. For doing this, over and above this drainage layer, I'll have to put the geogrid first and then put the geocell. And using geocell, there are specific methods, like all these cells are generally not opened up while taken from the factory. It needs to be put in place properly with wooden pegs or something like that. And then this material, say for example, if we use WMM and RAP in combination, this needs to be mixed outside and then put it on the geocell and maybe grade it by the grader, and then we need to compact it in the similar way. This geocell, polymer geocell material has been utilized in many road construction. It has got standard procedure. Probably each and every manufacturer will tell how it is to be placed. Like geogrid placement, there is no problem. It should be crosswise, not the lengthwise. And then geocells, we need to put it in such a way that the cells are open. And then we need to put this material there inside the cells and then compact it by roller. This is my understanding. Then the next question is, and as far as this, how it can be incorporated in PWD, I'd like to say that in the recent code of IRC 37, where IRC 37, this first method, that is stabilized RAP and stabilized, rather stabilized base and stabilized sub base, CTAB and CTSB. Now it is what is it called, allowed in IRC 37 also, and in many projects it is being used, and it can be utilized. Absolutely, there is no problem. The next question is from Mr. Santosh Pawar. This is RAP material used in cold weather condition. Sir, I could not understand your question probably, but let me assume something and then reply. This, as I said, that RAP is such a material that it can be utilized in each and every layer of bituminous material. It can be utilized in bituminous mix, hot mix we call it. It can be utilized in base, it can be utilized in sub-base, and in many places it is utilized in subgrade also. In one of the World Bank projects in UP for in Gujarat for GSSP2, Gujarat State Highway Development Project, where I was a part of the mission also. There they have used it in subgrade also. Now, for using this thing in base downwards, that means granular material, not in WMM material and not in bituminous material, I am not sure whether this weather has got any influence, whether it is cold weather or hot weather. But if it needs to be utilized in hot mix preparation, then my understanding is that hot mix design, the way it is done for that particular climatic condition, the similar way it is to be done. Only thing is that instead of virgin material, here you are using only RAP material. But my scope for this presentation is utilizing RAP only in the base and sub-base, not in the bituminous mix. The next question is from Ms. Manjula Devi. May I know the properties of geocell? I will not be able to tell it now. I have taken this material from a manufacturer in this Mumbai only, and this geocell properties I will be able to tell you from there, and it was taken from Strata Geosynthetics. I have taken this material. I can share these properties subsequently if I get the details. So it is possible. The next question is again from Mr. Santosh Pawar. Advantage of RAP material. I think it is a material at present, it is dumped. And many a times it is a problem. I have spoken with many concessionaire BOT operator with whom I am working as a consultant, because I am working as a consultant, and for many highway projects we are working. This RAP is being generated on a continuous basis, and initially the use of RAP started with in bituminous material, and it is observed that in bituminous material the performance of bituminous mix utilizing RAP was not as expected. So suddenly people stopped utilizing this, and after that I think in last few years the mix design of bituminous material using RAP has improved tremendously. This specific type of additives are also available. People started using, but base and sub-base utilization of RAP in base and sub-base has started recently, because it is now allowed with IRC also. And if you want to know the advantage of RAP material, I would say put it this way, that till recently it was a waste material. Even its disposal was a headache. Now, and based on the properties of the RAP, bituminous material and RAP material can be utilized in each and every layer of bituminous pavement. We need to see in which we need to establish the properties of the RAP material, and based on the properties of the available RAP material, we can identify in which layer it can be used as it is, or in which layer it can be utilized in by mixing it with different either virgin material or some other things. So it is definitely very, very useful. Not only we will be able to get rid of this problem associated with its disposal, but we'll be able to utilize is as a construction material. It will also save cost, and using wrap in many layers actually is life enhancing also, because wrap has got many good properties, especially it is rust resistant. It is called rust resistant materials. If it can be properly designed and used, wrap is very, very useful. And I think we should use that. Otherwise, a lot of material, it is just being dumped without utilizing it properly. And the next one is from Mr. Rishi. Informative presentation. Thank you very much. Thank you very much for this for liking it. Which method was followed for collecting wrap from site? What I have done is, as I said earlier, that I was associated, as I said, that I am working for more than 30 years. I am associated with many consultants. And as my testing and all other thing was in Mumbai, so I have collected this wrap material from Surat Dahisar, National Highway number 8. This project was developed by IRB. In fact, I designed it also when the detail engineering was done. I designed it for IRB. And I have got friends from whom I said that I need some wrap for my research purpose, and they have given this. And this wrap can be collected from any projects where it is being milled. And in fact, each and every projects wrap are milled on a very regular basis, because you cannot keep on laying bituminous overlay continuously. Not only the level will be increasing, and moreover performance of the strengthening also not proper if it is not milled and repaired and then put the strengthened layer. So collection means it depends on which purpose you want to use. If you want to use for research purpose, you will have to contact people, contact any contractor or concessionaire near to your location. If you tell them, they'll be more than happy to give it to you. And if it is for any commercial use, then probably you'll have to do the negotiation as it is required. Then it is from Mr. Dinesh More. How the use of different material as reinforcement affect the properties of wrap? As I said, the properties means it is physical properties. It is not chemical properties. I mean, there are two things. I mean, as I said, that the total activity was divided into two parts. One was stabilization, and another was reinforcement. And if I talk about reinforcing wrap, I mean, physical properties, that is load carrying capacity is enhanced, load carrying capacity of wrap, because there is a detailed load settlement diagram, detailed analysis. I mean, what is the load settlement behavior of wrap, and how the load settlement behavior of wrap is enhanced because of the use of reinforcing material, whether it is polymer geogrid or polymer geocell or combination of that, or bamboo geogrid, bamboo geocell, or combination of that. So it is only the load carrying capacity enhancement which we have studied. And in case of stabilization, there are two properties, as I said, try to say clearly that two properties which we are interested about. And the first one was how the CBR value is enhanced because of mixing with crusher waste and stabilizing with cement, various percentage of cement, and how the UCS value, unconfined compressive strength value of wrap is enhanced because of this mixing and stabilization. So I think these are the two aspects. And then will you suggest any other material as reinforcement for use wrap other than shown in? I mean, there could be any. I mean, I have used these two material. The purpose was like this. I have seen study to find out the improvement of load carrying capacity of wrap using geocell. That I have seen. Then first thing I try to do was I try to add geogrid also just to see. It is something like I try to put the load uniformly. I mean, the function of geocell and geogrid are completely different, as you know very well. But I wanted to put a uniform level surface, uniform strong surface, and then allow the geocell to function to its fullest. That's why I have used this two combination. And then I tried to find another reinforcement, which I thought that bamboo could be one, because the idea of using bamboo was I can say inclusiveness sort of thing, because huge amount of, I mean, the present trend is road connectivity, rural road connectivity, or BRTS. That means backward religious and tribal area connectivity. That means these are areas where roads are being constructed, and if the local people can also be involved in construction of roads and some sort of involving them in economic activities, so that local material using bamboo, if it is bamboo is used, they probably will take the bamboo from their area and then try to help in preparing these bamboo mats or something like that. As we know, in geotechnical engineering, this type of bio reinforcements are also used. Keeping that in mind only, I have considered this. Maybe you can consider other type of reinforcements also. I will not be able to tell any detail because I have done tests on using these type of reinforcements. Then the next one is Mr. Jayan Sani. Basis of WMM testing machine was fabricated, which I could not understand which WMM testing machine. I mean, this there are two things we have done. Over and above this regular testing, for this model testing, this loading arrangements, the way loading was applied, that arrangements was made in the institute, and this what is it called? The tank was fabricated specifically for this project, and there was no patent applied or anything like that. It was not done. Then the next question was from Mr. Dinesh More. How the length and width of the fail and geogrid can be dedicated? Are there any criteria which help to decide it? Also throw some light on research paper available on this. I mean, if the details are, if the contact things are available, then I can probably share some references which are available with me. Right. The first question I could not understand, how the length and width of the he, hell, and geogrid. So this I could not understand, the first part. Second part is regarding research papers. If details are available, I will be happy to share it. There is no problem. Next is Miss Manjula Devi. Any particular reason considering the marine clay? There are two things why marine clay was replaced. See, thing is that there are two basic things I have considered. One I have considered is very lightly loaded traffic. That means 10 MSA. And another one is the soil which is not good. Idea is, as I said, that my objective was to see whether inclusiveness can be brought into the picture because of this new development in the highway sector. Say, for example, if the national highway near Punjab is constructed, people probably will not try to construct the national highway on 3% CBR. They will try to do something else. People will not try to construct the national highway for 10 MSA road. I try to focus on the roads which are being constructed in the remote areas, like PMGSY roads or BRTS, backward religious and tribal area connectivity road. There could be two things. First thing is that it is not very heavily traffic road, so I have taken a lightly traffic road, that is 10 MSA only I have considered. And second thing is that in that area, there could be areas through which you need to take the road which are not as good. Where the soil condition is not as good as in Punjab or maybe in some part of Maharashtra or something like that. I mean, the load carrying capacity of the soil below might be very, very less. And as it is roads of a little lower category in terms of traffic, expected to be plying on it, huge amount of money to spend just to improve the ground there probably will not be feasible. Objective is to cover more length, construct more length at lesser money. So the requirement is also less, that is less heavily trafficked, either the lightly traffic road, and moreover it is in the remote area. So keeping these two things in mind, this was considered, right?
Thank you, sir. Thank you for taking so many queries. And for further discussion, we can share your email ID with the participants, and so that they can email you the rest of the queries.
That will be
Thank
fine.
you, sir, for a very nice presentation, and I appreciate your agreeing to present on behalf of Dr. Mandal. Thank you so much.
Thank you very much. Thank you.
So our next session is with Dr. Surendra Singh from IIT Madras at 2:30 p.m. So that's all for now. Thank you.